Today's lecture is centered around the virtual interface. Okay, so we'll talk about that from the beginning. First of all, consultation times on Zoom. So that's my, okay, so on Tuesday and Friday. So you just have to click that link. Make sure you have the Zoom installed on your PC, on your laptop. And then Ron, our tutor, is on Wednesday from 10 to 12. Okay, that's his also Zoom link. Okay. So this is the first concept of this unit. Okay, it's a user interface. Okay, so this is a part of the machine program, software, hardware that can handle how humans interacting with the machine, okay, or computers. So that's what we call in general user interface or interaction. So this is an image from about 40 years ago, how people interact with computer then. Okay, so you can see the monitor, you can see a keyboard, okay, people looking at them. Okay, so the question back here is that now is 2020, 40 years on later, 40 years later, what's are the main difference? You might be able to pick out, or maybe there's a bigger monitors, okay, there's a clearer and more colors, multiple colors monitors, and maybe the present missing of the mouse, okay, but that's not much difference. Okay, another main difference is also how people use the interacting with computer. In this case here is that there's no mouse invented then, and therefore people are using this line by line control command, which is you type one line just like your old typewriter. You just type one line and go to the next. Okay, which is changed from the introduced by Apple and Microsoft early version of the computer graph user interface or GUI. So that came with the mouse and keyboard, icon, click, drag, things like that you're all familiar with. So that is quite a subtle change over the past 40 years. Then the question what came about is that why do we need a new interface? We already have over many years ago in the past. What the kind of interface we can work with the machine. Why do we need a new interface? So some of these will highlight some of that needs. So first thing is an increased task complexity. So this one is basically as the task get bigger and bigger, not just data entry in the early age of computing, it become more difficult. Okay, so task is more complex, data become bigger. And of course, the volume itself. Okay, now with the era of big data, so this become a massive volume. You have to crunch in the big numbers and there's a multiple dimension, multitasking of the actual task. There are many things that associate with how people are required now to work with computers. And then there's amount information. So this is the big data errors. So there's a massive of them, how to analyze them, how to view them. This is still an ongoing work. And there's now start to be different forms of interface device. Tablet, phones, could be some of them could be a gesture, compute, narrative, that actually system that are available, ubiquitous and everywhere. So this is the form interface becomes changing. So that you can realize it now with the Google Home and Alexa with Amazon. So that's become a entirely different things. So that's why the understanding of this unit is how the interfaces sit inside that space is very important. And this is a common issues that's still working on. So hopefully this unit allow you to look at them in a different light. So this is usually the poorly designed interface that do not match well with the required task. So for example, they give you the wrong tool, the program is hard to understand how to use, and you have to spend a lot of time learning it just to use the way it was designed, not the way it was supposed to. It was not designed for the user. It was designed by the engineer and the designer for themselves. So that's oftentimes the problem that we have early on when people start working with computers. Okay. But nowadays, these things start to be moving toward the user-centric. So that's what I think we will cover hopefully you get the ideas for the rest of this unit. So one of the core concept of these is attention consumption. Okay, so this is where information is consumed. Okay, so like you read news, and it's basically the obvious one is that it's consumed the attention of you, the recipients. Okay, so there's a wealth of information. Okay, there's a lot of information you look through, just like you look in your internet, emails, and social media posts. But it's in the meantime, it creates these poverties of attention. You not necessarily can pay attention to certain thing and to require certain amount of time with adequate timing in attention. So a need to allocate that attention efficiently among the overabundant information source that might consume it. So this become a very key cluster of how you design the interface in today with the technology. It's not just what it can do, but it's more or less what the user can achieve with the system, the interface that you design. Okay, so this is, I will go back and repeat this in different form with the same message. So the idea here is about not just about creating something, but it's actually you have to make sure that what you create is actually well received by the user, and this unit will provide you with tools and framework for you to design those steps that you can follow, that hopefully you can get to the end and design something to be useful. Okay. So this is a quite common for information overload. Okay, so you open up email in the morning. Okay, so you will get a whole lot of emails or social posts that you find interesting, but that's in the interface area, or consumer consumption is actually quite challenged. So you might find yourself either miss the important emails or unable to process them, and it start to kind of bearing the weight on you, and you're unable to process, reduce your capacity significantly. So instead of you get more information, you get more productivity, it becomes the opposite. So the word user interface, okay, so there was a key components. There are only 3 key components there. Okay, in short, we call UI. So the first one is a hardware, of course, okay, all the thing that you can touch, computer, tablet, mouse, and keyboard. Okay, that's the fundamental hardware. And oftentimes we refer this as enabling component. So like it has a new gear, new software, new VR headset, new those sort of things. And then you have a software that run those hardware. So this one is basically communicate with all the hardware. Hardware could go into a different sensor type. Okay, then you're detecting your movements and display and head tracking, tracking location. But the software is the one that you make those components work. You can think about this as a tablet that needs a software to run operating system, iOS or Android. So for example, that would be the obvious example. And then this is the 2 components, okay? But then you can imagine your cell phone with a phone, certain phone that you have, and then you have the software operating system that running on it, Android or iOS. Then the key question here is that the user interface is really the bring them all together. It's a part of design, how to get those software, not just operating system, to work to bring the best out of the hardware for the user. So in this case, is that it's now the question become what do you want to them to do? For example, if you're talking about social media, okay, like Facebook, okay, if you want to get the people go together, so how do you design that? So that's design become these conceptual frameworks that you fit yourself into how the people creating the application. Like for example, Facebook application. So Facebook application needs to understand what people want to do. We call them tasks. Okay, and then what are they for their users? So for Facebook, probably you can attract for all kind of people. Okay. However, now the application, the design part, what the application should look like, that it serve the purpose they were designed for, and it had to be sitting on the first 2 components. What hardware they use. That's why the Facebook need the application. You want to available to all mobile phone, for example. Then you have to make it available on both hardware platform and the software. Okay. So that's it. Just kind of 3 components. You can think of the hardware as a hardware, something that you can touch. Software is something that running it, and design is that how you put the 2 together in a specific way in which people can use it, that your target user can use it. So that's a one paper here by my former PhD supervisor. He wrote this a while ago. So it's an easy read. So you can go to the Milo and look in and read them quick glance through them. So the title is Toward Tightly Coupling Human Interface. It's really suggesting the idea that actually humans and the machine need to have some way of coupling. Okay, and what are the challenges? Okay, so it will be interesting. You should spend time to read them. So this is in summary what is matching to humans look like. Okay, so some of these is understanding what is what are the humans, what we are, what are we. So humans are 3D spatial being. So we look at things, we operate inside three-dimensional space, X, Y, Z in the real world. Second, we build the mental models that create expectation. And this is a prime example of how people get more experience over time, over age. If they have more experience in the job, they have certain perspective, we think and process quicker. So that's how human can actually grow old, get more experience over time. And number three here, humans work best with 3D model control. So that means it's anything cash, just like you think about a toddler or a small children. So they tend to understand more with toys than actually in the physical space. Okay. This is been changing at the moment with the emerging of these 2D iPad screens and also the voice recognition software like Google Home. So that become changing. But naturally, when children come out and born, first few months they will try to grab their eyes adjusting. So that's is how human, and it carry on to the rest of our life, which is we are more familiar with those 3D more control. And humans, number four, humans are different from each other. So this is it may sound obvious, but this is where a lot of the designer in the past, early days of human-computer interactions, they make a mistake. So they tend to think what they think, since they don't have this assumption or understand this really clearly. What has happened to them is that they just decide what they think, they assume this will work for everyone else because they assume humans should work the same way. Okay, this is what just flagged the obvious, but the very important point. Number five here, human do not like to read instruction. So this is the best example to illustrate this is like if you are thinking about your parent generation when they try to use a certain software, then thick books, either a big training course, expensive training course, or a big book of instructions which you have to go through to be specialized into that. So that is creating a big problem for general people to use them. Like currently the software is very easy to use, like much easier to use nowadays, like all this Photoshop application. 25 years ago, it's only a very handful of people that actually going to be in a position to be able to acquire those skills to master those software because the way the design was so difficult to use. Nowadays things have changed, but that's what this number five principle has been very key into those. It's not always that they have to give them instruction and that they will read. So naturally, you want to look for other cue. Is there anything that instruction that could be combined between the one that require reading and require the one that not require reading? Maybe colors, maybe perceptions, environments. So these are kind of things just open up a floodgate of what possible. So this is a normal human experience. Okay, the diagram here is very simple. On the right hand is a world style on the green, and the humans is entity represented by the red dot on the left. So the interaction between them has reciprocal effect. So that means it's one direction that go from humans and you interacting with the world, and the other side is the world interacting with you. Okay, so this is how human perceive the world. So that's the arrow going from the world from the world on the right to the human on the left. And when human decide to maybe walking or moving objects, so that's the interaction. So they're interacting from the arrow at the bottom, from the humans on the left. Okay. and then move all the way to the world on the right. Okay, the world here could be anything that non-human. So this could be environments, objects, and anything so that. So this is our kind of core diagrams to use to describe how the interface sit in the whole thing here when people introduce interface system. Okay, so again, this is built on our diagram previously. So we have human on the left and world on the right. And the add part is the one we call mediation box, blue box in the middle. Okay, so that one sits right in the middle between the humans and the world. One thing that you should notice is that the direct perception arrow from right to left and the opposite at the bottom, direct action from the left to the right, remain the same, except that the blue box is creating additional layers. Just the same thing as normally you just interact with the physical object, and then suddenly someone putting a blue box, which is another application, let's just say iPad, then you're creating in the middle layer here that not that move directly in interacting with that blue in technology mediated experience. So within this mediation here, if you pay attention to it, on the left hand side when you interact with humans, so now remember if you go to this mediation here, humans are no longer directly interacting with the world. They just go through this box. So you can see here on the left hand side, so people interacting with this box by looking at them, what they were talking about, display. This could be a visual, could be audio, could be conversations, anything that come back to the human. Opposite side is the action that the human decides to do. So this could be interaction. On the other side, which is so we won't cover much in this unit at all, because this is a back end really about the technical side where the chip, the programmings are working. So this one is, you can see here the mediation box will creating an action to the world, and the world creating provide a sensor information movements, and then have it to the sensor box to calculate. So this is a part of those sensor device and tracking mechanics and computers. It's not the focus of this unit. So this unit is pretty much focused on how humans are interacting with this blue box, so the red and the blue. Okay. So this is just highlight again. Okay. So human on the left hand side. Okay. And then the machine on the center. Okay. So this is just a few examples of what it looked like, the experience that you're interacting not directly to the world, you're interacting to this machine that we call a technological mediated experience. So this is a couple simulation. Okay, the one on the left is a flight simulator. Okay, with a 3D panel, 3 panels surround. And then you have all the mechanic that you interact with. So this is a well-known flight simulator. So that people can use the train before they fly the real plane. On the right-hand side is actually a medical surgery process, very specific in certain area, medical procedures. So in this case, the surgeon will practice or simulate what it could look like for the actual patient that they're about to schedule to go into the operating room. So this one will be give a surgeon a way to practice them. But it's also can be used for a medical student to practice on this to get the feel, understand. The difference in this is that this one provide force feedback, okay, into what the person hold, okay. So in this case here is that instead of the surgeon is really just playing a video game. So all this, including the one flight simulator on the left, it's actually have a force feedback, which generate a force that simulate those cutting the tissue on the right hand side, or you are simulating a wind, the strong G, and those type of things make the handling of the airplanes tougher. So this is a part of those simulated experience. So the other one is more layback. Okay, this is a record experience. So this is generally mean someone has already produced some contents, and television would be the good example to demonstrate this point. So someone is there, and then you just review them. Okay, it could be a TV show, it could be other part, it could be the capture of the mining tunnel that the drone just flow in and get you those experience. So remember here, people now just interacting with this is, you know, no in the record experience, there's no interaction. You just simply observe, okay, which should happen a lot with the content that we have. Okay, it's just have to recognize some of that. And this one is a slightly different experience. It's real time. Okay, it's a called transmit experience. So this one is actually experience is actually happening real. Unlike the simulation a couple of slides ago, when the what happened there could be completely simulated. Most of the time, it's simulated. It's not connected to real world. The record experience that can happen in a real. A lot of them are happening in real time, like television broadcasting. But it's a record experience. Okay, so it records somewhere else and play it here. This one is actually it's happening live. Okay, live that you can interact with. So this one, the image of people, a soldier operating a tank. You can see here the tank is running in the field. However, he not really actually open up the one in the tank here is operating by looking to that binocular, that telescope that allow him to look outside and see the target. Okay, so this is what we call transmit experience. The reason we make a difference here is that because there was amount of engineering work to get the outside capture outside the scene to transmit it inside. Okay, it's the view, the view of the camera, the optics and things like that. In this case, might be just optics. So those binocular kind of things, but it's more complicated, and you probably have the night vision that's allow them to see more. So this one, the way we see them, we need to understand that the actually experience is actually transmitted through that system. So this one is also it's also a good example. This one is more linked to our unit, okay, immersive experience. So in this case here, this is where about 20 year plus of the VR in the 90s, okay, at the first peak of VR, okay, so that's within the 90s. There's a lot of people there. They're try to do the VR. So you can see this one has, you know, a headset, okay, a headset, and you have a glove that be able to detect your hands, and people are running, walking inside immersive experience component. When we say experience here, one thing that make the difference in immersive is unlike the other, they're looking to a small set of display, either binocular for the tank, or a screen for a flight simulator, or a surgery medical procedure simulation. This one is actually you're looking to screen too. However, the screen is not fixed, so it doesn't mean it's fixed on your headset. Okay. However, you can move around with your normal. Unlike other part, you cannot turn your head around and then look at other non-display component. In this case, as you move your head around, the scene will move accordingly, adjust accordingly, so it reflects like you're inside the immersive component. So this is where immersive is coming in. It's not just go in there and see everything in the display. The display still have limitation. In the current VR, it's about 100 degree field of view. However, with immersive means you can turn around 360 and you will feel like you have the display around you. Okay, so that's a combination of head tracking, combination of relatively larger field of view of the current VR. You will get those. Okay, so this is one type of working experience. So how about this? Okay, so this one is very different. I think I like this one because it's combined between both. Okay, this is a nursing, the human medicine, which is a simulation of the human medicines that simulate for study. We have here up in Newnham's from the nursing school has this. Okay, so called SimMan, which is really this one is generating. They can generate a symptom. Okay, so you not actually have a display. Okay, so you not actually have a display. You interact directly, so you can measure the heart rate by putting on the real that look like a real patient. The look form in the form of real patient. The difference here is that it actually provides a feedback. So that means that it has a heart rate, heartbeat that you can hear, that you can practice on. Okay, you can practice injecting the needle into the patient, into this human medicine patient, and then is the human medicine also strapped it in just like real patient strapped the equipment to the instrument that's showing all this bio signal that usually you will see in the operating room. So this is a very useful for simulation. Again, the form factor is very different than the flight simulator we've seen earlier. So this one is more focused on the physical, tangible appearance of the object, okay, which is simulate closer to what they have. Think about this. You can think about a flight simulator. They have a console that mimic or has a resemble to those. All this commercial flight, Boeing 747, 777. Those has a console that exactly duplicate one to one in details. This is the same thing. The patient look very similar. Okay, so look to the real patient. So when you design the interface, you sort of see this in kind of how the people interact, what the patient, the doctor was using this for. So in this case, it was for training medical student, nursing student to kind of see that. And one thing with the simulation here is that you control something that normally you can control what they're exposed to, the condition, just like the flight simulator and others, all the simulator. You can create an environment in which our ordinary for a part of practice, part of training. Now, just to conclude this, so we've seen a different type of interface. Okay, so this interface will always going to be is our core. Okay, so I just like to highlight again from Tom Furnet's paper. They summarize some of the key challenge here. Okay, so that we're moving forward with interface. So the first one here, what are the most useful and effective method to creating the interface of the future? So this one is getting like, okay, you might say, hey, okay, so we just build something and we'll see how people like it. Yeah, that may be one of ways, okay. But this is it's 20 years on, I think this is not very much, it's still very relevant. What I consider useful, not just what you can do, as I said earlier, not just what you can do, but what you actually should do or should design and develop. Number two here, okay, what are the most appropriate metrics and method for determining when we are on the right track? For example, if you're building a prototype app, prototype games, those type of things interface, how do you know what are the method in which you want to measure? You can tell that, okay, this has a good sense that we should continue to develop this further, that this is in the right track, that we are actually, the game, for example, is useful, people will like it. Yeah, so this is a question. This would eventually along in this semester be turned into some sort of related to usability. Okay, so how to define it, how to design a question, that's what we'll cover in a few weeks time. Okay, how to test the software, so determine whether they are doing okay, your application is doing okay. Number three here, so what innovative components appliance will be possible and how would they be used? So this one is actually a bit of a creativity. Okay. So how is it possible? What components? So this is allow you to have a bit of more fun with the new technology. It's centered around innovation. What happens if someone build a new sensor? What can we do now? Just same thing, similar to the current situation in the way that the VR headset now is being given to us or can be purchased from the commercial. But that is how do you get creative with this new technology? It's very, very limitless in a sense. So that's why hopefully this unit will allow you to get a hands-on experience with this headset and hardware, so you get a feel for it, and then you generate with the design. Remember the three components: hardware, software, and design, and allow the design, your own design, to take it further. And number four here, how will we sort of in a very very general sense, so we call it bandwidth to the brain. Okay, so this is essentially here, how do we actually enable the human intelligence that we know we already have, but we being limited by the way we interact with computer, like limited using mouse, keyboard, or very traditional sense that actually limited how to interact with them. does it actually create a bottleneck for the bandwidth? Think about a pipe that actually has some leak or has some cottage, so you kind of stuck there, that you only do as much. Okay, so this is number 4 here. Is really a big chance today. How we do increase the bandwidth to the brain, expand human intelligence to make use of media information available to us. So this is a hopefully sum up some of the chance. Okay, some of the key. This is a key chance that we're moving forward. We will touch base on this from time to time during the semester. This is the next 2 slides about virtual interface. Okay, so in the user interface lecture previously, we talked about what outline as what we consider interface change. Okay, so this is one of the way in which we are looking at investigate that one of the tools. So one of the key tools to navigate through this is called virtual interface, which we will talk about this in this lecture. So to overcome those interface paradigm shift, the way we're thinking about how we interface computer need to be changed. So again, this is what previously mentioned on the matching machine to humans. Okay, so the humans are 3D spatial, building mental models, work best with 3D model control, different from each other, doesn't like to read instruction. Okay, so this is very much the key how to map to human. If we want to do well, we need to kind of try to assess this individual, this, and try to map them, okay, and match them. So let's look at the current computer interface. Okay, first one is that they're not take advantage of human being a 3D spatial being. So presentation in 2D, even the presentation slide that you see now is a 2D. So you don't basically it's work because humans are made to adapt, but it's really not take full advantage of that. Okay, the second point, display field of view. So this one, the field of view here regarding how many degree in front of you, you can see generally field human normal eyesight will generate about 180 degree field of view. So that's just basically from your left ear to your right ear. So across the front part of your view. Okay, so that's measured in degree. Okay, so in this case here, the human eyes can actually, as you might not know, you could notice is that when we focus on things, we look at using our center of your focal, of your basically human visual system to look, concentrate, just like everything you look at. Okay, you pay attention to. However, there was a kind of we call a peripheral, okay, visual system, which is the one on the far left, close to the far right and far left, okay, which you use for human to use that for other things, for stabilizations and for that standing upright, and also for avoid accident in the real world, those sort of things. But the computer interface is with the monitor as big as a monitor you might have. You still have the very limited field of view. That's a very clear way to look at them is that if you look at your monitor, can you still, at the corner of your eye, can you still see something else? So yes, the answer is yes. So because you're not really inside that content, you just look outside looking. So therefore, that is not really fully utilized. It doesn't mean that you always have to completely fill the field of view, but that is something that oftentimes is a problem, okay, because you are, for example, if the field of view of applications are very tiny, it would allow you to work less effective, and sometimes can cause a real problem. Okay, so this is one of those that try to address what the current states are. Number 3, so this is described in terms of outside looking in. So the user, think about the metaphor, the same example I used before earlier about people looking at the monitor. So that you're outside looking in. You not actually explore perceptual organization of human. For example, if you are just imagine a working desk that you have at home, okay, at your apartment. Just remove computer out. Okay, just remove your normal computer laptops out of the table, and then you have many things: coffee mugs, and lamps, and paper, and things like that. So what we refer to as a perceptual organization here is that you'll be able to function in that space once you get familiar with them, because human mind can actually map things inside their head with their perceptual organization. Okay, so for example, where you put your marks and how to grab your pen without having to look for them specifically. So that is a ability that humans are born with, okay, and grew up and has more experience with. However, the current computer interface is actually kind of remove all those, because now everything you do is actually sit on side that 2D screen monitor that you have. So you can still access some of this perceptual organization where your icon is, where you do this and things that are on the screen, but it only limited. It's linked to number 2, field of view a little bit, FOV, because essentially here you just only allowed to use a capability in a very small area. It's much smaller than you could normally operate. Okay. Number 4, information is still highly coded. Okay, therefore interface require user to be computer-like. What it means is that everything is still you have to understand them before you actually learn about them, how to use it. This would be let's say a new application on your mobile phone, for example. You download a new game, so as much as they're still there, you still require quite a bit of learning. And it depends if this application is more complicated, then you really have a proper learnings to do. So therefore, information is highly coded. It's not always user friendly. Okay, so therefore, this is ongoing that computers some application today and some do better than the others. Okay, but not all the same. So this is just trying to give you a snapshot of what the computing systems look at are at looking from the interface designer point of view. So this is our diagram again with our humans in the world and the mediation box from the previous lecture. Okay, so this one is actually just to kind of give you the idea that we are now focused on this one. Okay, so virtual interface is really centered around this mediation box in the blue one in the middle, how to do with the display, measure action, or not much on the right hand side, the sensor actuator. But those are kind of what it could be possible. Okay, and remember the arrow from the top and the bottom is still exists. Okay, even though you only focus on the machine side, but how people for example, the bottom link, direct action, how humans are interacting with the world will affect how mediation box are sensing and reacting to the world. Okay, and vice versa with the direct perception as well. So the purpose of the virtual interface, okay, is basically to overcome these human-machine coupling issues, okay, that we talked about so far. Interface to be able to provide the bandwidth to the brain through matching the organization or portrayal of digital data stream, so digital information, to human sensory or perceptual, cognitive, and model capability of the humans. So essentially, virtual interface were designed to match between between the content you have available and who you are as a human and a human ability. However, the interface here, when we create this, okay, so since you match between the two, the normal game here is that you can try to find the middle ground. However, it's difficult to change human sensory. It fundamentally we take many million of years to evolve into the human as today. So this is really difficult to change that sense. Okay? The field of view, the capability of attention. So it's more advanced and more flexible to change or adapt at the computer interface. And that becomes the virtual interface, which is really something to design how information should be displayed, how application to interact with the humans, which should be, in this case, assume is fixed. Okay, fixed sensory ability for humans are fixed. We just need to raise our virtual interface to match those. So the goal of the virtual interface is to make the computer human-like rather than computer-like. Okay, so human-like doesn't mean that it always have a human face. It's just human behavior-like, to be specific. So how people react, what people perception of these look like. So you should try to make it so that humans feel like this is part of them or something that they can easily interact with. So hopefully This virtual interface provide you umbrella term, what we are about to embark in this unit. So the definition of the virtual interface. Okay, so this one just to go into a bit of details. So the term virtual interface is at the input output modality, which if you go back to my diagram, the blue technology box in the middle of those diagram, you will look at this. There's input, there's output, looking at the direction of the arrows. Okay, a system of transducer, signal processing, computer hardware, and software to create an interactive medium through which information, number one, is transmitted to the sense in the form of 2 or 3D or three-dimensional virtual contents. So this could be a content, could be image, could be the objects, could be anything that are interactable. Okay, so this is a part of it. Second purpose that you can deliver the interactive mediums is to psychomotor or physiological behavior of the user is monitored and used to manipulate the virtual contents. So you again, if you go back to look at diagram, you will see that it's not just about which you have an interface and a button for them to click and select. Okay, the action of what you do and how you move could impact the way in which the next action the computer or application are reacting or present it back to you. So the understanding how people behavior of the user is important to understand how the application should be designed. So this couple of slides here is talking about the general definition, so I won't spend too much time on this one. So just quickly, sense, so this is a sense of pain, balance, joy, sense of time, temperature, directions. Human motors is how people move their hands, fingers, and arms. And this first one, physiological. This one basically a branch of biology, change the behavior, result motion sickness. So anything sweat, motion sickness, and ability to move, and breathing, chest cavity pop up and down, things like that. So anything that not necessarily you can control, it's just your heart keep pumping, even though you might be unconscious or subconsciously. But the other second term here, psychomotors, so that one is actually ability for you to it's linked to your cognitive components, so origination of movements in conscious mental activity. So this one it get involved not just non-control or subconscious activity like heartbeat and breathing and all the internal function, but this one requires some skill like driving a car, hand-eye coordination using the mouse and keyboard. So that's in understand of some of those terms. Perception. Perception here is a very general terms, a very big terms, quite significant. We will try to touch on this later in the semester. It's quite complex. It has psychology, it has other bit components that go into it. But it's process of obtaining awareness, understanding from what we see, sensory process. Okay, so this is a very um, big implication of complex research. Cognition is also a mental process involved in gaining knowledge, including thinking, knowing, and solving the problem with perceptual process. So they, in some way, they're linked with perception. Okay, in some way that for you to make sense, you need to perceive them. For example, you go into a new space area, into a new building, for example, you need to look at around the building. Let's say you want to look around the building and then you want, let's say, to find a toilet. In the new building you've never been before, so you need to look first, right? So that's a sensory process. So you acquire by your own eyesight, look around, and what is a cognition come in? How do you know where to go for the for the toilet? In that case, so in that case, you have to go build into the mental model we talked about in the previous lecture. How people are looking at, oh, they have to look for sign. Okay, so that's creating a mental process to process. Oh, I have to look for sign. I need to look for or directory. Uh, Maybe in the building available there, and say, all right, this is give you a direction. Then let's say you find a map on the directory that say, okay, this is where you're going to the toilet, which is 2 or 3 turns from here. What do you do then? Then you have to navigate yourself there. So that's is a you have to process understanding, not just look at what you see, but it's actually try to make sense of it. And that's in a nutshell, that's a cognition component. Okay. So the concept of these, of the virtual interface, the core concept of this is centered around this duality of virtual interface. Okay, this diagram would show you what the duality of the virtual interface is. Okay, it's really highlight two very key components of this interface. First one is start with technology side. Okay, what is it? Okay, what the technology is. Okay, what are they? What the piece of hardware, software? Okay, what can we do? Okay, what is it? Okay, so this is regardless of what it's supposed to do. Okay. The second on the right hand side, remember the whole thing here, the duality is a conceptual frameworks. Okay, just try to think of those. So on the right hand side is experience size, what it does, what it's supposed to do. It doesn't matter what technology is or how it make it happen. Just same thing you look at your mobile phone, it doesn't matter how the back end hardware processors are running, what it's supposed to do. But what is experience size look at what it's supposed to do for you. Okay, so can you make a phone call? Can you chat with your friend through the different social network application? I mean, all those things. Yeah. Hopefully you get these two sides kind of clear. Okay, the technology. So when you describe this, you should describe to them is how this works. Okay, so what it's supposed to be, what are we looking at, an experience size of what it's capable of doing. Okay. Now, there was a link in the middle, and that's what this diagram is powerful in this sense, is that you're looking at this purple two-directional arrow here in the middle, link between the two of them. This is where the virtual interface is sitting, okay, where you have to balance between both of them. It's neither technology or the experience side completely, but sit in the middle. That's why the bottom of that has a new affordance within the virtual environment. So this is where you can think of someone that come in with a designer with idea will think, oh, I have this piece of technology. What can we do with this one? Okay, the very classic example for this one, the people who done it right is Apple when they first generated the mouse. Okay, the history is that a team led by Steve Jobs went to a Xerox PARC, which is another think tank up in Silicon Valley, and see this device, which is it's a mouse with a roll ball before the optic device. So they say, oh, okay, what is this? So the device is really just a sensing device, how you move, how the ball roll, and then they just detect those. And then they'd be able to display back on the screen. Now, that's what the genius of those Apple designer team is. They spin into the right-hand side. Then what that can do with those, they give them a name, a mouse, okay, and then they give them application, and then they shift the paradigm of how personal computers should be interact, changing the command line that I showed you in the previous slide into a completely moving GUI, and then basically moving icon on the screen, creating a mapping of those screens, as limited as they are as a field of view, but it allows them to see where they click, where they're going. Okay, so that is a very, very powerful thing. And hopefully that this concept will keep revisiting, that you keep revisiting and keep remind yourself of what you try to do here when you design application. It's not just to think about what your application can do, but it's actually what the actual is capable of doing. Okay, so this is linked back to this hardware technology, hardware, software, and the design that we talked about in previous lecture. So hopefully you get the idea here. Okay, so basically what it does is really the hardware and the hardware size. Okay, it's the experience size is what it's capable of doing. The design is really about everything else. That actually, how would you make the hardware and the software work in certain way to achieve the application goals? Okay. So this one is really a Mingram reality, virtual reality continuum, just to give you the kind of idea, complete the next couple of slides of what is this that people think. So in this case, there's two extreme. On the left-hand side, real world component, virtual environments on the right-hand side, completely virtual. And we have the continuum, which is a red line there, which is a continuum of spectrum. And this one is actually right in the middle, is augmented reality, which is one of the key of our focus of our unit, which is where the virtual contents kind of coexist in the real world. In this case, it's a little animator character sitting on a physical card that the lady holds. And we have another area. This one we not have much in the practical, but it's sort of augmented virtuality. So in this case, it's actually the opposite. You actually bring the real world inside the virtual components. You might not see well from the image there. So essentially, this is a virtual environment, like a virtual flower shop. But in there, there's a physical, there's a teleport, like a Skype of a real person that actually sitting on one of the location. So that is a very interesting one. And also, you can think about that some of the information in the virtual can be can be captured in the real world and ported in real time. So that is augmented virtual reality, virtual reality. Okay, so this hopefully you get the spectrum. The full spectrum here is a very simple, real and the virtual. Okay, and then somewhere else in between. That's why our units are focused on mixed reality rather than augmented reality alone. Because mixed is actually anything between the real and the virtual, in anything between, including the AR. So this is, I think, last slide. Okay, just give you a feel of what the virtual interface. Okay, I put in a perspective of this unit. So we have the top. Let me go to the convention here representation. So the C, capital C in the yellow block box. So that is a computer. Okay, computer generate contents. And capital R, so that is the real world, okay, where the contents, so the real world. So in the top right left hand corner, so that's a GUI, graphical user interface. So the humans in the blue, of course, and you can see here there was clear communication between the human in the blue and the computer contents, just like your laptop. Okay, however, there are disconnect. We call it gap, but it's disconnect with what happened in the real world. So that's in example of a laptop would mean laptop could be sitting on the table that I talked about previous example in your working desk at home, but they have no relation with your physical world at all. So that's a gap. So you can move. The advantage is you can move the computer and go somewhere else. You continue to work on that computer, interacting with that computer generated content. Now moving to the top right hand corner, that's a virtual reality. So that's all the VR headset, immersive experience. Okay, so this one, humans actually not outside looking in like this on the GUI on the left hand side. So virtual reality in B here, they're actually inside environments, as I talked about before in what you mean by immersive experience. So so that when you move around in that space, including rotating your head around, you will see this content surrounding you. Okay, feel like you feel like you're immersed by that. One of the things that come from that is that you are completely disconnect from the real world here, which is capital R, which is sit outside of that. So that means you can think of a good example would be you put in a VR headset, okay, and then you completely disconnect from the real world. You don't know how your friends outside are looking at you, okay. So that's one of the things. So this is just to give you a kind of a diagram to give you a good understanding into it. In the next few slide, few lecture, we will talk about this more when you go into the VR. How does it look? What's the advantage? What the disadvantage? Now we're looking at bottom. Now pay attention to the next is to the bottom right. So that augmented interaction. So this one is AR, augmented reality. So in this case, you have the human. Okay, you look at the real world. You sit inside the real world, capital R, and you have a contents right in the middle. Okay, you're not necessarily looking at two different things. Okay, so in this case, in AR, it specifically make them so they're aligned. So everything the human do, okay, they're interacting with R. They have to see through or go through the component in C, which is a capital C. So that's what the term means, augmentation. So they're just not, unlike the virtual reality, VR, they are completely inside that. So you don't have a view of real world at all. This one, you have full view of real world, but you actually look through your content. So that's allow your content to be superimposed, like virtual character in a location, like Pokemon Go, the monster inside the real world. Okay. And then you have this C, which is the bottom left, ubiquitous computing. this is fuel is now fueling driving by what we call ubiquitous is quite a general term, but IoT, Internet of Things. So where all the computing bits is now spread everywhere, in the light bulb, in the motion sensor, computer, camera generator. All those things sit inside the real world. You're not directly interacting with them, but they actually compute and observe how you're going about your thing, which is a very interesting one. It's not the focus of this unit per se, but it's kind of good to know, interesting to look at this space because it's coming. So hopefully you understand this virtual interface a bit better. Okay, so in a few next slide, our next lecture, we'll kind of try to revisit this and firm it and strengthen this component specific example, for example, like VR and AR stuff. All right.